everyone, welcome to today's video. Today I'll be discussing about introduction of measurement and instrumentation. As I have discussed in the previous video, measurement and instrumentation is a very important subject for the students of electrical engineering department. It is taught in the second year of BTech course. This is very important for recording and measuring data, whatever experiment or whatever analysis the students are doing or whatever analysis the engineers are doing in future. For all those purpose, this measurement part is very important. That is why this subject measurement and instrumentation is included in the syllabus. So in each and every phase of life this measurement is very important. So I will begin with today's lecture. So this is measurement and instrumentation. I will discuss about the first module in this lecture. I will start the first module because it cannot be covered in a single lecture. So this is the first lecture of module 1. Okay, that is measurements. So introduction. Now why measurement is required and what is measurement? Okay, so measurement is an act. Okay, it is nothing but it is an act of measuring any quantity. Now what is measuring? Measuring is comparing the quantity whichever we are measuring with some standard value. That is called measurement. Every measurement has got some standard value. Suppose I am giving an example. Suppose our body temperature. What is our body temperature? It is in degree, it is 37 degree, right? In degree Celsius, it is 37 degrees Celsius. So usually the human body temperature is 37 degrees Celsius. Now suppose you are having some illness. Okay, you are having some kind of illness and you are not feeling well, so you are feeling that you are having fever. Now how to know that you are having fever or not? That is another question, right? So for that what we do, we use a thermometer. Now thermometer is again a measuring instrument. What it does, it measures temperature, right? So what we do, we'll measure our body temperature with the help of a thermometer. So thermometer, if the thermometer is showing our body temperature as suppose 37.1, so we'll say then no, it is okay. That normal is 37, then only 0.1% is increasing, then it is of no harm, right? It is okay. But suppose your temperature is 38 or 39, then it is very serious, right? Your body temp, it is very higher than your normal body temperature. So you will say that I am having fever because it is not showing normal value. Normal body temperature it is not showing. So what we are doing, we are comparing our body temperature with a standard value, right? So that is in measurement. It is an act of comparing the quantity with the measured quantity, of course, the measured quantity with some standard value. Okay, so that is what is written in the example as well. Definition as well. The measurement of a given quantity is essentially an act or the result of comparison between quantity whose magnitude is unknown and a predefined standard. Since two quantities are compared, the result is expressed in numerical values. Okay, two quantities are compared, so the result will be expressed in numerical values. So measurements are expressed in terms of numerical values. Okay, that is again an important point. Next, what is the significance of measurement? Like I told you in the example taken, that it is important to know whether you are having fever or not. So for that, what comes into play? Measurements come into play. By doing measurement of your body temperature, you have come to know that no, you are ill and you are not normal, so you need a doctor or you need some medicine. So it shows that we are not normal in general, by taking the example which I took, right? In that, by considering that as reference, we can say that this is an important method, an important technique, which is very important, right? So now let me tell you, another thing, many experiments, many innovations, many inventions are going on all over this world, right? So these inventions, if you want to prove that your invention is correct, if you want to prove that your discovery is correct, what you need to do, you need to present your result in some way. You need to present your result. Now in order to present a result, you need some numerical values. If it is some experimental invention, you are finding out the, suppose, formula of something, or you are finding out the mass of something, then you need to prove that. So what is the way of proving? You will show that no, this I have done this calculation, and I have done this as my result. Suppose you are discovering a new theorem, okay? So the theorem, or suppose you are discovering a new technique, optimization technique, suppose. So there are many optimization techniques available. Now optimization techniques which you have developed, what you will do in order to establish your technique, you will have to compare the results obtained by the previous techniques, and compare both the results obtained by previous technique and the results obtained by your technique, by using your technique. You will compare both the results, and then you will come to know that yes, by using my technique also I am more or less getting the same result, or I am getting better result, right? So this is just one example to show that for scientific development also we need measurement, because we need to prove our discoveries, we need to prove our inventions. For that also measurement comes into play. You are doing some experiments, some chemical, suppose you have discovered some chemical element, okay? So what is the mass, what is the weight, what is everything, you will have to find out. So for that again you need measurement techniques, otherwise how will you establish that whatever you have discovered is correct? So this is the significance of measurements. It is very important in each and every phase of life. It is very important in science and technology, and development of science and technology, in establishment of new inventions and discoveries and everything, okay? So this is the significance of measurement. Yeah. Then let us come to methods of measurement. Now measurement, all of you must have understood. Now there are several methods which are used for measurement. Broadly they are classified into two methods: direct method and indirect method, okay? So direct method, as the name suggests, it is such a method which directly gives the value of the measure, the quantity being measured. By using that instrument, or by directly measuring the value of the quantity, you can get the output, you can get the value of the quantity being measured. That is called direct method. Suppose you are measuring current flowing in a circuit, you will have use a ammeter and you will measure the current, right? So this is what directly we can apply ammeter and find out the current flowing. So that is direct method, by which we can directly find out the result. Next is indirect method. Now what is indirect method? You will have to convert your data obtained in some other form, and then again reconstruct it from in the final output form. You will not get that, whatever output of the quantity, whatever is the value of the quantity, you will not get it directly. You will have to use some other techniques to find it out. You will have to express it in some other terms, okay? The output, which the quantity which is being measured, it is always expressed in some other terms, okay? And then again, in the last step, the data is retrieved from the modified form. So that is again another type of measurement, which is called indirect measurement. Next is instrument. These are few terms which are very important and which will be used frequently in the upcoming lectures and in the whole course. So I am discussing all these things. Next is instrument. What is instrument? The instrument is a device, right, which is used for measuring, which is used for measurement of any quantity. That device is called instrument. See, measurement generally involves using an instrument as a physical means determining a quantity or variable. Whatever quantity or variable we are measuring, we are finding out, that is found out with the help of instrument, okay? Next is instrumentation. So instrument, you have understood, it is a device which is used for measuring purpose, for measurement of some unknown quantity. And the technique of measuring is known as instrumentation. Instrumentation is the use of measuring instruments to monitor and control a process. Okay, so it is a technique of measuring, it is a method of controlling and monitoring, we can say, or in simple words you can say it is the technique of measuring the quantity being measured. Okay, that is called instrumentation. Now next is measurand. Now we'll come to measurements. So one another term which is important is measurand. What is measurand? Measurand is the quantity which is being measured. Whatever quantity which we are measuring, that quantity is known as measurand in technical term. Okay, in technical term, the quantity which is being measured. Suppose we are measuring current, then current will be measurand. We are measuring voltage, then current, then the voltage will be measurand. So that technique, sorry, the physical quantity which is being measured is known as measurand. Then measurand can be of two types. Again, what are the types? Fundamental quantity and derived quantity. Now what is fundamental quantity and what is derived quantity? So measurand, I hope you have understood. Fundamental quantity is such a quantity which is obtained directly, which you can measure directly, and which is expressed in, like, it is not expressed in some other variable or parameter. Okay, like length, or which you can directly measure. Okay, which you can directly measure. Suppose length, we can easily measure length of by using a scale, by using a tape. We can measure length of a rod, we can measure length of road, right? We can use all these things. So directly we are measuring and finding out the value of length, mass, right? Then mass, we can use the weight balance. By using that weight balance, we can directly get the value of mass. So we obtain these things directly. They are expressed in terms, in direct form. Length, mass, time. What is the unit of length? It is meter. What is the unit of mass? It is kg, right? What is the unit of time? Second. All these things we are obtaining directly. So these are known as fundamental quantities. Now what is derived quantity? Suppose speed. Speed is what? It is distance by time, right? It is the change in how much distance is covered in how much time. That is rate of change of distance, right? So that is speed, distance by time. So for finding out speed, you need distance, you need time. But to find out length, you do not need anything, isn't it? You do not need any other quantity. You just can measure length. But speed you will, for measuring speed or for calculating speed, you will need length, I mean distance, and you need time. Similarly for pressure, you will need another quantity. Similarly for acceleration, what is that? Meter per second square, length by time square, right? So all these things are derived, we cannot find out directly. All these are derived from the fundamental quantity. So these are known as derived quantity, and fundamental quantities which can be obtained directly, derived quantity which we obtain with the help of fundamental quantities, that are known as derived quantity. Now see this diagram here. What happens? How can we get the output? That is what I have shown here. This is process, some process. Okay, some process, and it is giving some input. This is the system which is measuring. Okay, so what we will get? There is some input, we will definitely get some output. Okay, so the input which is fed to the measurement system is the true value. Okay, that is the actual value, or that is the reference value. Okay, that is the standard value. So the input is always the true value of the variable, of the quantity being measured. It is fed to the measurement system. Measurement system will measure and give you the output. Okay, it is giving you the output. Now whatever value we have obtained after the measurement system as output is known as measured value, because it is measured with the help of measurement system. So these are known as measured values. Okay, so these are measured value or variable, and here we are the observer, we will be seeing this. Okay, so the input which is fed to the measurement system is called the true value, and the output which is obtained from the measurement system is called the measured value. Any value or any reading calculated from measurement system or measuring system is the measured value. Okay, as I have told you, this measured value, it is obtained with the help of measurement system. So whatever is obtained with the help of measurement system, that is known as the measured value. Now true value, any value calculated from rated value is known as true value or actual value. Rated value, okay, that is the rated value of any instrument or any quantity. Okay, that is a rated value. That rated value can be obtained by calculation or it can be obtained directly. So that is a rated value, that is known as true value. And whatever value we have obtained after the measurement system, or whatever the output is given by the measurement system, that is known as the measured value. Okay, so true value is fed to the measurement system, and we obtain measured value as the output. Now another important term comes error. Now what is error? Okay, what is error? Error is any deviation of measured value from true value. Any deviation from from the true value. Like I took the example of our body temperature. Again, I will take the same example. How did you come to know that you are having fever? See, your body temperature was 37, should have been 37. Normally, body temperature is 37, but after measurement, you found out that your body temperature is 38. Okay, so that is not normal. There is normally is 37, but you are getting 38, so there is some deviation, right? There is deviation from the true value 37. What is that deviation? That deviation is of 1 degree Celsius. Okay, so this deviation is known as error. There is something wrong. Okay, when your body temperature increases, you will realize that there is something wrong. So that wrong thing is the error. Okay, so it is the deviation of measured value from true value and is known as error. What is the formula? Error is equal to measured minus true value. Measured value minus true value, that will give you error. Okay, this is very important. Error calculation is very important. I will in the future lectures I will also give some examples of error calculation. There are many formulas related to this error, and we need calculation, which is very important for the exam purpose again. So I will discuss in the upcoming lectures. Okay, I'll come to this error part later on. I just gave you the definition of error, and I'll come to the explanations later on. Okay, for the time being, let me go to the classifications of instruments. Now, as I have given you the classification of measurement methods. Now here is classification of instruments. Now in there are different types of instruments available in the world. Okay, so basically there are 7 types of classifications which are discussed. First is absolute and secondary instruments, analog and digital instruments, mechanical, electric and electronic instruments, active and passive instruments, manual and automatic instruments, self-contained and remote indicating instruments, deflection and null output instruments. So these are the 7 classifications of instruments. Now I one by one I'll discuss each and every classification. So first one is absolute instrument. Absolute instrument gives the magnitude of quantity under measurement in terms of physical constants of the instrument. Some instruments have got some physical constants. So the measurement, the quantity is expressed in that terms of those physical constants. So that type of instruments are known as absolute instruments, where you do not find the answer directly. You do not find the quantity being measured, the value of the quantity being measured directly. Okay, it will be in terms of physical constants of the instruments. These type of instruments, one example is tangent galvanometer. Okay, in this type of instrument, no calibration or comparison with other instruments is required. Calibration, I will come to calibration later on. So there is no calibration required in this type of absolute instruments, and there is no comparison required. Calibration is nothing but comparison with a standard instrument, so that is also not required in case of absolute instruments. Now they are generally not used in laboratories, are seldom used in practice by electricians and engineers. So these are actually not in so much use. These are not used by engineers and electricians and everyone. This is outdated, you can say. Okay, next is secondary instruments. Now these type of instruments are what you can directly measure with the help of these instruments. You can directly measure the quantity with the help of these instruments. So these type of instruments are known as secondary instruments. These instruments are calibrated. Like the previous one, there was no calibration required, but in this type of instrument, the instrument is already calibrated. Okay, by comparing with some other instrument. Example of this type of instrument are ammeter and voltmeter, with which we can directly measure voltage and current. Okay, these are two examples. There can be many other examples. Okay, so this is secondary instruments. So analog instrument is such an instrument which which express the output in terms of the physical constant of the instrument, and secondary instruments are what they will directly give the result, they will directly give the output of the measurement. Okay, there is no calibration required in analog instrument, but here analog in secondary instruments calibration is required. Okay, next is analog and digital instruments. Okay, so what is analog instrument? So see, there are different types of signals present: analog signal, discrete signal. Okay, analog signals means it is a continuous waveform, it is a continuous signal, there is no break. Okay, so the instruments which work on those principle of continuity are known as analog instruments. The signal of an analog unity vary in a continuous fashion. It varies in a continuous fashion. Okay, in any fashion it varies in a continuous fashion. But it is continuous, it is not breaking. Okay, so those instruments which are based on this principle are known as ammeters and voltmeters. Like ammeters and ammeters and voltmeters, you can keep on measuring current, you can keep on measuring voltage. Okay, with the help of this. But digital instruments are what they work on discrete steps. The signals are not continuous, the signals are discrete, 1 0 1 0, that you will learn in your future semesters. Signal varies in discrete steps and taking no finite number of different values in given range as digital signals. Example, timer on a scoreboard. Have you seen timer on a scoreboard? You will come to know what I'm talking about. It blinks, right? It is not giving the output continuously, it blinks. One means it is giving output, 0 means it is not giving output. So 1 0 1 0 1 0, it keeps on blinking. Okay, so that is not giving a continuous output. That does not depend on actually continuous signal, that depends on discrete signal. So these type of instruments are known as digital instruments. Okay, example of analog instrument, as I have told you, ammeter and voltmeter, the conventional ammeter and voltmeter. And digital instruments, you must have used digital watch. Yes, you will find blinking sign on that watch, then you will understand. You just go through it, you will understand what is the difference. Okay, so that is digital instruments. Now mechanical instruments. So this is I have come to another classification: mechanical, electrical and electronics. Now mechanical instruments are those instruments which are bulky in nature. These are very big. Okay, these are static devices, these are static instruments, big instruments, bulky static instruments, and due to their bulky nature they give output very slowly. Okay, they get there are many disadvantages like slow output, unable to respond rapidly. Okay, so these type of instruments are known as mechanical instruments. Electrical instruments, um, they are less bulky than the mechanical instruments, but the response time is better than mechanical instruments, but still it is not the best. Electrical methods of indicating the output of detectors are more rapid than mechanical methods. Okay, electrical methods are more rapid than mechanical methods. Then comes electronic instruments, those instruments which are very fast in response. Nowadays most of the instruments which are there in the market are of electronic in nature, so they give very fast response due to the presence of devices, the semiconductor, due to the presence of semiconductor, the response of those instruments is very fast. Okay, so those type of instruments are known as electronic instruments. The advantage is that it is very fast in response, and it is not bulkier at all. Okay, it is lightweight, so that is an advantage of electronic instruments. Now I'll move to another classification, that is active instrument and passive instruments. The quantity being measured simply modulates the magnitude of some external power source. Active means it has got some power source of its own. Okay, but passive instruments, they do not have their own power source. Some external power source have to be fed. The instrument has to be fed with some external power source to operate. But in active instruments, it has got its own source of power. Next is manual instruments. Manual instruments are those instruments which need manual interference, which need manual intervention to control or operate the instruments. Those, or in short, I can say they need operator to operate. So the manual instruments require the services of an operator. Okay, those type of instruments are called manual instruments. Automatic instruments, as the name suggests, it's automatic. It does not require any type of any operator. It does not require any type of manual intervention, human intervention. Okay, so those type of instruments are known as automatic instrument. Then comes another classification, that is self-contained instruments and remote indicating instruments. Self-contained, what does it self means? Self means me, myself, right? Self-contained, contained means it is there, everything is there. So self-contained instruments means those type of instruments which can function on its own, which has got each and every component of its own to operate. It does not depend on any other uh, parameter, any other foreign body or foreign instrument or parameter. It has got every bit of parts required to get to measure the quantity. Okay, those type of instruments are known as self-contained instruments. The different elements of a self-contained instruments are contained in one physical assembly. In one physical assembly everything is there. What is remote indicating instruments? Remote means it is far away. Okay, remote indicating instruments, so those type of instruments which in which all the parts are not incorporated in a single physical quantity. One part is here, other part is somewhere else. I'll give you an example of remote indicating instruments. In future, if possible, visit a power plant, you will come to know what I'm talking about. Okay, in power plant, boiler are there, right? In thermal power plant, boiler will be there. So they have got, to measure temperature, they have got some devices fixed on its body to measure temperature. Okay, but obviously because the temperature will be very high, you cannot touch and find out, you right? So you cannot measure it by using a thermometer as well. So you need, there is some instrument, some device which is fixed on the boiler, and it will sense the temperature. The temperature it will sense will be displaced in the control center. Now the control center is there in the power plant too, at the control unit where everything is getting operated with the help of computer. Okay, so that will sense there, and the temperature will be displayed in the control center. So this is what the control center cannot measure the temperature by itself, and the computer cannot display the result by itself. It will have to take the help of the instrument that is placed on the boiler to measure the temperature, right? So this is called remote indicating instrument, where the indicating instrument is somewhere else and sensing element is somewhere else, right? That is sensing the temperature, that is somewhere else, and the one which is indicating it is somewhere else. So this type of instruments are known as remote indicating instruments. Now another classification is null output instrument and deflection type instrument. Now what is null output instrument? Null output instruments are a type of instrument where you will have to adjust the instrument in such a manner that you are not getting any output. Null means zero, you are not getting any output. In null type instrument, the physical effect caused by the quantity being measured is nullified. Okay, it is nullified by generating an equivalent opposing effect. The example I can say it is a potentiometer. We always we always adjust the potentiometer at such a place where it gives zero output, right? Where it gives zero output. So those type of instruments are known as null output instruments, in which we have to nullify the quantity being measured, right? Effect we have to nullify. So those type of instruments are known as null output instruments. Deflection type instruments, which will give deflection, from the initial position. Suppose the initial position is 0, you are measuring current, it will give 5 ampere, or it is showing 5 ampere. That means the particular circuit or particular connection is in that connection 5 ampere current is flowing. So that is how can we find out that? By the deflection of the pointer of the voltmeter or the pointer of the current ammeter, right? So with the help of deflection of the pointer, we can find out what is the quantity being measured in general. What is the quantity, how much is the quantity that is being measured, right? So we'll get output like that. So those type of instruments are known as deflection type instruments. Example, I have told you ammeter and voltmeter are one type of deflection instrument, right? So these are the different classifications of instruments. Now so for for this lecture, for today's video lecture, I will stop here. If you have any doubt, any query regarding any of the slides and any particular topic, you can comment and let me know. Okay, so in the next module I will start the other topics of the first module. So see you then. Thank you for your time and patience.